I start because I have quite a lot of material. Welcome to this presentation about which I call container evolution from single container to applications at scale. And before I go more into detail what I want to talk about, I would like to introduce myself. So my name is Hardy. I am working for Red Hat. I was for a very long time member of the Hibernate team until I just last year switched to a team which is called Developer Tooling Team. And our task is to find the best ways for developers out there to interact and use OpenShift. We also try to provide tooling for OpenShift, which means, for example, integration into Eclipse and so on. Who in here hasn't used Docker yet? Who has used Docker? Who knows what? Everyone. Okay, so I don't have to do a lot of Docker things. Kubernetes, 1. OpenShift 3, that is, 1. Okay, cool. So normally this is a little bit a longer presentation. I talk and do a lot of demos also with Docker, but I try to keep that short to have a lot of time for some OpenShift demos. I still kind of want to motivate the whole container story and what's going on there, and kind of talk quickly about virtual machines versus containers. What's the benefit of containers? I guess, since all of you guys use Docker, you don't need convincing anymore. But in a virtual machine, you basically have your hardware, and then on top of with your OS and kernel, on top of that, you're running a virtualized hardware on which you're running again some operating system on which you're running your application. So a lot of layers you have to go through. Whereas on a container, you have your hardware, you're running Linux on top of it, and then basically each container is its own process. That's it. So it's much more, much better resource utilization if you're in the container world, and it's also much faster. It kind of on this machine, I can start up 100 Nginx servers within 35 seconds. I could not start 100 Nginx virtual machines on this machine in that time. It's just not possible. Okay, as I just mentioned, containers technology. It's basically just a process, but kind of make sure that containers cannot interact with each other. You have to isolate them. So each container has its own mount points, its own net stack, its own PIDs. Each container via C groups has its own resources, so it can only use a certain amount of CPU, RAM, or I/O. And I thought we do a little bit of Docker stuff, and I'm hoping this is something which you don't see so often. It's not as a typical Docker run or Docker start/stop command. What I'm trying to do is so I'm running here a Docker container busybox, which is a minimal Linux distribution, and I'm opening a shell onto this. So I guess since you guys all used Docker before, that seems to be an interactive shell against a running Docker container. Docker PS. Here a little tick maybe. I always use this. So if you don't have an alias, I highly recommend to put an alias on Docker PS pipe less-s. Most of the Docker outputs, which is kind of ordered in columns, it's kind of always, no matter how wide you terminal it will always line break. So if you kind of pipe it through less, you actually have a much nicer aligned output. This is a container ID. I can go docker top. Docker top DA3. So and this here is the PID of this shell, right? Of this container, which runs a shell. If I now go onto the machine running my Docker daemon. So in this case, since I'm running OS 10, or if you're using Linux, you cannot use Docker on the machine itself. You need the virtual box which runs Docker. I guess every one of you knows that as well. So Docker provides this toolset called Docker Machine, which allows you to basically use Docker where the Docker daemon runs in a virtual machine, and you kind of, via the command line tool, interact with this daemon. So what I'm doing now, I'm kind of logging into this virtual machine, which actually runs my Docker daemon, and I do a PS on this PID, and that's my PID. So if I would kind of start multiple containers, I still would kind of see all these processes appear on my host. And in fact, I can use this to kind of send signals to this process, kind of completely bypassing, so to say, my container. And I think it's just a nice way to see, kind of really to visualize how containers work. Okay, a few words about Docker. I kind of already used it now because it's partly because it's a default standard nowadays in the container world. However, the technology which makes Docker possible has been around for a very long time. Initially, it was based on Linux containers. What Docker did, they kind of made it easy to kind of do all these namespaces and C groups and stuff. They gave you a simple API to start, stop, remove containers, and so on. They also came up with this idea of a Docker hub, so you can create containers or images and push them into the hub so that other people can consume it and build on them, which is a great way of sharing. But I think the really genius move by Docker, the thing which kind of really makes Docker stand out, is the concept of the layered file system, because this is really what makes Docker special and which enables you actually to really reuse containers and kind of reorganize them. So who knows how this layered file system works? Who has thought about this a little bit? So the idea behind Docker is that a container or an image is based on multiple layers. And each layer kind of make changes to the file system. But each layer is separate. And then there's something called an overlay FS, an overlay file system, so which overlays all the kind of layers. And then once you start the container, you basically just get a very thin read-writable layer on top of things. So if you make any changes to the file system or any changes at all, this is where it kind of gets stored. Whereas all the underlying layers stay untouched, which has the advantage I kind of can reuse the same image multiple times. You collect the same image, can spawn multiple containers of the same type. And of course, these layers can be rearranged or kind of reused, and so on. So that's really, I think, the great thing which Docker added into this mix of Linux containers and this whole container technology stuff. A little bit, so you guys all use Docker. Do you use it kind of for your personal development or for production already? So personal development, production already, someone has things, okay. So most people I meet, they kind of also try to use Docker to kind of improve the personal developer in performance or workflows, whereas production, I don't see that many yet. I think it's really just more developing. But just as a point, if you haven't done it yet, Docker is a great tool to kind of do software exploration. For your job, you need to evaluate another NoSQL database. So instead of what you used to do was installing MongoDB or installing Redis on your host, you just need Docker, start the latest Redis container, explore your software, like it or not, throw it away, or if you like it, you can then kind of then use Redis on the host, or you can kind of, let's try to go the Docker approach and kind of develop my software against a Redis instance running in a container. I want to talk about the second point a little bit more, the isolated development environment. And that was for me basically the eye-opener where I go like, this whole container thing is going somewhere which it kind of might change or will change the way we are going to develop applications in the future. So far, we kind of only thought about as a developer, I write my application and I maybe produce a WAR file or like in the Java world or jar file, or I basically just, if it's a non-compiled language, I generate some JavaScript files. And then somewhere they will be placed on a server and somehow they will get run and so on. In the container world, you kind of think much more holistic. You think about your code and your actual kind of application code, but then also about the whole environment. So when I was working at Hibernate, that was like 1 or 2 years back, a few of us decided we are rewriting our website. And we decided to use a static tool called Austruct. Anyone heard of that, Austruct? It's a Java, Ruby-based tool, which basically you write your HTML pages in ASCII doc or something. You run this code generator, Austruct, you get static HTML pages, and then you can host them wherever you want. So we did that. So like 2 or 3 of us sat down and kind of did the framework. Most of the content was created. And then we kind of went out to the rest of the team and go like, look, let's sit together for a week, finish the content, and off we go. Any Ruby developers here? Okay, so I love Ruby. I use it a lot, but Ruby is a true pain in the ass when it comes to trying to get the development environment working on, say, Windows or Fedora. Native extensions are just a super pain. Kind of on some computers they compile and work, and others not. So what happened was that 2 or 3 in the team, they basically go, we can't get this development environment running. We can't get Autoscale to run, and we don't want to spend the time to get this to run. And they wanted to pull the plug on this thing. So we spent 2 weeks and said, like, we throw it out. And there we said, 2 of us said, hang on, what if we can provide you a runtime environment for that? And that's what we basically did. So one of us sat down, and this is kind of the Docker file syntax. And the point was these guys were using Fedora, and they were kind of saying, we can't get it to run on Fedora. So this Docker file or this image even proved, okay, if you go through these steps, you actually could also get it to run on your box. But this apart, we have a container now for you. You're just checking out your source code on your host. You're starting this container. You're mounting your checkout of this website into this container. So all the compilation and generation of the static HTML pages happens there, but you still can edit your source code on your host with your favorite editor. And we did that, and they kind of went along, and we switched in the end to Autoscale. And for me, this was an eye-opener. Like, this changes, this is amazing. This kind of changes the way how I think about applications and how I should ship them and how I should bundle them. Also, maybe the last one, microservice development. This becomes really relevant also then. Docker plays a role there, but I think especially OpenShift and Kubernetes will play a very big role there. Everyone is talking about microservice architectures. But what if I have an architecture with like 9, 10 different microservices? As a developer, I maybe work with one, but I most likely need a quite large subset of these other services somewhere available to me so that I can test and run these interactions. And it kind of becomes very easily quite like very hard for people. Like, you cannot get every single developer. You have to install all these kind of dependencies, all these little microservices on your machine, and kind of manage them and stuff. And there is something where Kubernetes and OpenShift can come in, where you basically quite easily can have multiple different containers which interact, and you can have one OpenShift instance running on your local host as a development environment, running your services, and then potentially the service you're working on, you kind of still develop on the host. But you need you need a way to kind of get this whole environment running for you as a developer. And preferably, you want this environment, again, as close as possible to staging, and then later production. So usually, I kind of do a little bit of Docker stuff now. I will skip that because I want to spend a little bit more time on OpenShift. A few words about Kubernetes. Anyone heard of Kubernetes? So while Docker was sorting out their Docker stuff, and they kind of went through several iterations, people started saying, okay, I have Docker, I can run a single container. But what if I need multiple containers? What if my application is not, even if I can start multiple containers on one host, my application has to spread out or be clustered across multiple nodes to handle a load, or to different applications or different parts of the applications on different nodes. So you have to kind of scale this whole concept of containers. And Google was one of the first guys on the market who kind of took this further. Docker, in the meantime, caught up with something which is called Docker Swarm. I don't know if you heard about that. It's still, I think, behind Kubernetes because Docker basically had to sort out their business in the core, in the Docker engine, so to say. And Swarm fell a little bit behind, but they are catching up. But Kubernetes is Google's answer, and a lot of big players in the industry kind of backed Kubernetes, Red Hat, for example. And the idea is the following. You have one master, which potentially in a highly available installation would have kind of some backups for the master. And then you have the nodes. So they are also sometimes called minions. And on each of these minions, there's a Docker daemon running. So here's the connection, the evolution kind of thing. You know, initially I had one Docker daemon, and now I have basically one Docker daemon on each single node. And on each node, there can then be containers be run on this Docker daemon. Kubernetes also introduces a concept of a pod. So instead of making the smallest deployable unit a container, they are saying the smallest deployable unit is a pod. And the pod can be a single container or multiple containers. And the idea here is, for example, in some cases, it might be beneficial to really have two containers running on, making sure that two containers run on the same node. So the pods give you this quite easily. I know, database is maybe a bad example, but like if you think about it, often you want to have that two parts of your architecture. It's beneficial, like maybe the network connection or the communication between them can be faster if they are literally on the same host. Right, the whole thing is based on etc daemon. So Google actually developed etc daemon as a base work for groundwork for Kubernetes. And etc daemon is basically a distributed, clustered key value store. And that's underneath kind of makes sure that all the nodes or like everything sees the right state. So every node knows which containers to run and what the others know, how to reach the other nodes, and so on. Again, there's much more to say. There's a whole universe spawning around just Kubernetes. There's a package manager which is developing for Kubernetes called Helm. I have a little bit of some demos for that as well, but I want to skip that again. So you can run Kubernetes yourself or standalone without anything else. And that's basically, the key concept here is how do I cluster my containers? But the focus is still on containers, whereas now OpenShift, which sits on top of Kubernetes, and it's basically just a superset. So anything you can do in Kubernetes will work in OpenShift as well. Or if you're interacting, so OpenShift itself will run underneath the Kubernetes instance or infrastructure. So if I, for example, interact via the Kubernetes command line tools with Kubernetes of OpenShift, and then use the OpenShift console to look at my state of my cluster, I will see all this as well. So it's like, it's really a superset. But the center or the focus of OpenShift, of OpenShift 3, I should say, is more the application or container application platform. It's more the whole application, not so much or the single containers anymore. So what kind of OpenShift adds into the mix? It's source code management. So there in OpenShift you can say, here is my Git repository. Please monitor this Git repository. So if a user pushes something into this Git repository, pull down the changes, and then there's something called source to image. So there's a builder container which takes a source code and say it's Java. It compiles the code, it creates a Java file, it puts it into a Wildfly container, it creates a Docker container out of it, and deploys it into OpenShift. So that's source to image. It's also things like image management and promotion. OpenShift has this concept of image streams, for example, where you find, okay, here's my image stream for a given application. If a new image for this application is pushed, I will automatically, for example, one configuration option is to do this automatically. As soon as an image gets available, I will deploy this new image. And if it works, it's fine. If it doesn't work, you then can manually roll back to the previous image. It's application management. So OpenShift adds a console where you can kind of see the different application. It kind of adds a whole concept about users. So each user has his own project and can create applications and containers. So it's much more focused around the whole application and not just a single container. How do you get started with OpenShift? There are many ways. I think one of the easiest would be the CDK. That's something Red Hat develops. It's called the Container Development Kit. You will be able in a week or so to download it for free if you're signing up for developers.redhat.com. It doesn't cost, all you need is kind of signing up for. And then you can follow the download link to get the CDK. And what it does, it's kind of similar to what Docker Machine does. Instead of running a virtual machine which just runs a Docker daemon, you're getting a virtual machine running OpenShift And in this case, the master and the nodes are all on one machine. So this is by no means a production thing. It's a purely development environment and an environment where you can fully explore OpenShift. But once you want to kind of really use that in production or something, you have to kind of find the right infrastructure and put it on multiple nodes in a clustered environment. The architecture is very, very similar. You recognize the pictures with the pods, with the nodes and the master, potentially one on standby. Then on the left, there's maybe a little bit interesting. It has really this view, the developer view, which maybe interacts with OpenShift by the source control management tool like Git or SVN or something, or maybe the developer acts with one continuous integration or continuous deployment pipeline. So he pushes something to Jenkins, or Jenkins picks it up, and Jenkins will push things into OpenShift. And then there's this whole view of the operations of OpenShift, where someone has to kind of provide the infrastructure. The OpenShift needs storage, so containers, like if you want to, once you kind of leave the playing grounds around, like if you work with containers, a lot of examples are just like, start this Docker container, and it's like data is not persistent at all. It's kind of just the simplest use case. If you want to kind of do things real, you for example, would have to make sure that database data does not get lost. It still has to get somewhere into your persistent storage. So you need a way to kind of hook up persistent storage into this cluster. You need a routing layer. OpenShift provides that as well. So OpenShift is very focused around web applications. So once you create an application, OpenShift uses something which is called the HP proxy, which is able to kind of route. You have basically one host or one HP proxy taking requests from multiple applications, and depending on the host header, it kind of routes the traffic to the right application within your cluster. Okay, so that was a lot of, I think things will become easier if we look a little bit at OpenShift. I log out just to give you the login experience. So that's OpenShift Enterprise, so OpenShift Origin. So OpenShift Origin is the open source version, so you can just go and get it. It's on GitHub. And then Red Hat takes OpenShift Origin and makes it commercial, rebrands it as OpenShift Enterprise, which is still all open source, and then sells support for OpenShift Enterprise, whereas you don't get support for OpenShift Origin. So I'm logging in here. So you have a project, you can have multiple projects, and each project can have multiple containers. Let's see. Let's start with, I want to kind of demo, before I use this little application which exists here, I definitely want to make sure that to show you guys how to do with OpenShift a very simple blue-green deployment. That's another buzzword you probably guys have heard. Anyone heard, who knows what blue-green deployment is? Oh, no, that's not so many. So the idea behind blue-green deployment is I have two environments which are kind of almost identical, or actually they should be identical. I develop my application, and okay, here's one version of my application. I put that out, call that blue. And now development kind of continues, you're making changes, and now you're ready for production. So instead of now kind of taking this new code or this new application and basically overriding blue and sitting there, okay, oh, maybe it works, maybe not, you're putting this updated application on the second infrastructure you have. So that's then the green environment. You can also actually internally test it, but then the idea is to basically just via the network routing to say, okay, now I take my traffic and I don't route to blue anymore, I route to green. And people will automatically directly see the green application. And now you can say, okay, if everything is fine, you just keep it. At some stage, you can kind of then shut down the blue environment, or then use the blue environment for the next iteration of your software. And that's the beauty of this blue-green deployment. If something goes wrong, you discover a bug, a big problem, you can immediately switch back to the old environment and kind of this keeps running, and you kind of troubleshoot the thing you just deployed. So that's this blue-green concept. It has, there are problems like if you do database migration and stuff, you have to kind of think how you want to do that, because if your new update makes database changes, then you kind of have a problem with this. But there are strategies to kind of work around that. Let's try to do a blue-green. So what we see here, there are kind of in OpenShift, there are some templates defined per default, which helps you to getting started. So like there is Wildfly or JBoss EEP templates. There are templates for PHP application, for Perl, for Node.js. I will go here for PHP one. And I call this blue. The repository URL is URL for this demo here. So now I need some advanced options. The context here, that's basically, if you look at the Git repository, the PHP code I'm after is in subdirectory. That's what I'm kind of OpenShift blue-green, what I'm specifying here. And what I want to do now is disabling this. So per default, if you create an application in OpenShift, it will create an external-facing route for you so that people then can reach your application. In my case, I don't want this to happen right now because I want to I need to control that manually. So I go create. So now you see here we have a build running. We can actually look at the build. And this is also this source to image. So like here something goes out to GitHub, gets the source, and there is something which knows, okay, this is a PHP application. What do I have to do to get a PHP application into a Docker container to be run somewhere on the cluster? You can look at the logs of the build, and the last thing will always be successfully pushed something. So there's a certain namespace built up on these Docker daemons, and kind of if you do your build of the Docker container, at some stage there will always be, okay, now I'm pushing into OpenShift, into first into the OpenShift Docker registry, and this will be a trigger for Kubernetes and OpenShift to take this container and kind of decide on which node it kind of gets to run. So now we should actually, so now we have one pod running of this blue application. The problem here is there is, like if we, the concept here is of a service. So if I click here, I have a service blue, which kind of exposes over here port 8080. But there's no ability kind of to reach this thing yet. And that's where routes come in. And I want to do that in the command line. So the console is nice and good. That's nice to get an overview of what's running, and I kind of get some metrics and stuff. But really, as a developer, that's my opinion, your main entry point is always OC, which is the command line client for OpenShift. And everything you can do, and much more, everything you can do in the console, you can do with OC, and much more. A lot of functionality is not exposed in the console. So what are we doing here? OC expose. So that's kind of now expose this application. The service was called blue, so expose our service blue. Give it a name, blue-green, so that I can identify this. It's called a route. And give it a host name, blue-green 10.122 xipio. Route expose. And if I go back here, you see, just before there was actually no route, and it kind of updated immediately. So if I go here, I hopefully get a blue application. It's a PHP application, and the only thing I do is I kind of dump out the blue rectangle. Everyone with me so far? Cool. A little tip, if you ever get into OpenShift development and stuff, one problem you will face as a developer is that to make these kind of application works on your host, you have to get your browsers to resolve these host names, right? So if you type something into your browser bar, your browser will go to your host and go like, I need a DNS resolve for this host name, which gives me an IP, which kind of then goes via HTTP to this IP and gets the content. On a local host, that's not so easy. You can't, because these kind of URLs or these kind of hosts are not routable in the World Wide Web. They are kind of just local to your environment. So one little trick here, and we are working on other things like certain plugins and stuff, and running DNS servers locally on your host. But one thing which doesn't require any additional configuration for you on the host is something called XIPIO, which is a DNS server running in the World Wide Web, in the internet. And what it does is actually you encode the IP it's supposed to return in the URL. So that's the reason why I'm calling it Bluegreen 10.122 XIPIO. If this gets sent to the XIPIO DNS server, it will return 10.122. And that's per default the network IP I use on my host to communicate with the virtual machine. Does that make sense? So this is a really good trick because this comes up all the time. Okay. Let's now do the, hello? I must be here somewhere. Yep. So this is this PHP application, and I'm kind of really lazy here now. I just kind of comment this line out. And so now what's happening is like, we have our Blue application deployed, everything is happy, people are using it, and now the development team goes away and kind of implements new features and bug fixes and whatnot. So my bug fix or my feature is to kind of change these two lines. Am I here? Exit. Yeah. So I'm kind of committing this change now. So again, in OpenShift now, if you kind of want to have a different type of interaction or experience, you can also configure OpenShift to kind of via GitHub or webhooks to react on this push already and kind of start the deployment. But I kind of did not want to do that because that would not work in our example here. Okay, so we know the application has changed. What we're doing now is we add a second PHP. We call it green. It's the same GitHub repository. And we need advanced. It was OpenShift Bluegreen and no routing. And then there's a whole bunch of other things you can configure. You can also, like down here, that's maybe interesting. You can kind of put resource constraints onto this application or onto these containers. How much CPU or how much memory can they consume? That gets, hopefully I have time for the second demo. That gets interesting when you do auto-scaling. You can use OpenShift to say, here's my container, here's my application, runs on one pod. And then it kind of monitors the CPU, and you can say, if CPU goes over 80%, which would kind of imply that maybe you get a lot of traffic, scale automatically up to 5, 10 pods, whatever. So you have an automatic scaling. You don't need any interaction if you suddenly get a surge in traffic. We can see here. So now the green is building. Will take a few seconds. And I guess you kind of already kind of see now where this is going. So now I basically, once this is completed, I will have a green service against the same source code, but again, not exposed by any route. The route sits on top of the blue service. So now it's scaling up. Now it kind of recreates a pod. And again, like here, for example, you can do the manually via the console, the scaling. If you wanted to, you can. So that basically means now, instead of kind of one instance of this application, now I suddenly have two, which are kind of distributed in your cluster, or in my case on the single host. Okay, so the thing we need to do now is I use a command called ocedit, and the thing, if you remember, I called the route blue-green. So I said I want to edit the route blue-green, which gives me some YAML, and then somewhere here it says, basically this route kind of points to the service blue. So if I go here and change that. Green. And this should also kind of reflect instantly. So now you see already the route has changed to green. So if I click here, I should get a green rectangle, hopefully. And I mean, a lot of people talk about blue-green. It makes a lot of sense. You can do that by no means. You can do that without OpenShift, no question. But here, you almost get it for free, and you get the whole infrastructure with clustering your containerized applications. Does that make sense so far? Yeah.
Is there another way to edit the configuration without going into VI?
Yeah, so you can edit the thing. Actually, the same question came up when I was giving the presentation before. What we are missing here, what you want is like an OC edit command, which does just explicitly that. That does not exist, but I think I passed on the feedback, and I think that's something which is coming. If you want to skip the VI, which is, it works fine, but I guess your concern is it's not scriptable. If you want to script things, you do OC delete route blue-green OC create, which is like 2 commands, and it's instant as well. There is no difference really in speed here, and that's fully scriptable. That's like 2 independent commands. OC edit, sure, it's not really so nicely scriptable. You would have to use like pipe it through SED, and it doesn't make sense. Rightio. So I think we have a few more minutes. Then let's talk a little bit about autoscaling as well. And I mean, here you see kind of so here you have the overview over all the applications in your project, or all your containers running in your project. You can kind of just look at your pods. So for example, if we are looking at this Nodejs example, which was already running, there's some nice things which actually, so for example, you can actually go into the container and get the logs on the container. Even better, you get a shell into the container. And this is just sugar, and that's kind of why I always think it's important. I was saying initially, whatever you learn in Docker will be valuable for Kubernetes and OpenShift. I mean, this is really it. I mean, yes, I can use a console, but if I can also kind of go to the Docker daemon, to the node which runs this thing, and use docker exec-it bash. And this kind of knowledge is never lost. In fact, this is sometimes quite limiting, and if you kind of remember, hang on, this is really just a Docker container. What do I do? I kind of just find the Docker daemon, and I rely on my Docker knowledge instead of kind of trying to figure out some OpenShift or Kubernetes way. So sure, you can get started with OpenShift of Kubernetes just like this and kind of get just to know the OC command line, but I think you will be missing out. I think you get a better understanding of the system if you also understand the concepts of Docker and kind of know a little bit how to play with Docker. Anyways, what I wanted to show, I don't have any, I have to do something like this. So this is kind of the metrics I have been talking about a little bit. You can show kind of the resource utilization of the pods in as well in the console, and you can use this, and I hope this works now, to do the auto scaling. So I have a few more minutes. I try to get to see if I can. So this Node.js example runs on a single pod. So the first thing you have to do to kind of make auto scaling work at all is you have to set a resource limit. So actions. No. No, it's on the deployment. So sometimes it's really hard. It's a little bit confusing where to look at. Do you look at the configuration of a pod or of the build config? Hopefully here, set resource limits. It's already done. So here we are saying there's a resource limit on the CPU usage this application can get. What you have to do as a second step is OpenShift Autoscale. So there's an OC autoscale command. You're saying which kind of deployment to autoscale. In this case, it's this Node.js example. You say minimum 1 pod, maximum 3 pods. And in this example, I would use a very low CPU percentage to kind of get the trigger here. like this. So now it creates this autoscaler for me. OC get HPA. So that this, unfortunately, always that's it's partly because it's all on one host, but in general, this whole metrics framework needs a fair bit of work. It's quite slow to kind of reach the statistics to reach the master or wherever it has to go. So sometimes there's a little bit. Okay, so now we have zero load on this application. What I'm running here is that's Apache testing tool framework to kind of put load on websites, AB, and I just kind of trying to hit this site now with continuous requests. And we are going back here. So this might take, again, it takes a while to propagate these changes. You can always also look here, so nothing happens. We can take a little bit some questions, and hopefully while we're taking the question at some stage, we should see that down here, the pods are scaling up to 3. Sorry? Yeah. It should. But here it's happening now. See, the scaling is happening. It should, but I have problems. I had problems in the demo to get it to work. I'm not sure if there's a bug or what's going on. So this is a little bit of a word of caution here. OpenShift is great, but there are rough edges to it. I say that as it is. There are really rough edges to it. So I think it's ready to kind of to use it. It's ready even for production, but you will hit corner cases where you go, hang on, this should work and maybe it doesn't work. So there's maybe still a bug, or there's thing. It could be a little bit nicer here. I wonder why I don't do that. It's basically in its infancy, but the potential, I think, is really there. Any more questions? Yeah.
Are you using the autoscaling features in Kubernetes, or do you do?
Say again.
Are you using the autoscaling features in Kubernetes, or do you do something special here?
Yeah, it comes from what's happening here. There's this additional metrics framework called Hawkular installed, which is this one, which kind of keeps the metrics. And I mean, this is basically just another container. It doesn't really matter if in Kubernetes or OpenShift. It's basically as part containers which kind of do the work. So it's nothing really specific to it here. But you need some sort of framework, and I think there are different, like we in OpenShift at the moment use this Hawkular, and then I think in Kubernetes, so there's another framework called Cockpit or something, which comes more out of the Kubernetes world, which is also in the same, like this whole monitoring thing. So there are kind of multiple efforts, and it might be that this is not the final framework which will be used under the hood, but the API, the whole concept of auto-scaling will be there. Also, like it will also automatically downscale. If it's configured correctly, but this I think might change. I'm not sure how stable this is yet. Any more questions?
If I set up my development environment locally, how much do I have to do to transfer it to the cloud?
To the cloud, if it really into the cloud, into OpenShift public or something. None? If you set it up, it depends. I mean, there are multiples. I should, if you're happy with the source to image, you can kind of develop locally, and then, for example, by a push into repo, get OpenShift public, which doesn't exist yet, but will be there soon. And you can host it there. Or, I mean, it doesn't really matter if you run your own OpenShift cluster, OpenShift Enterprise or Origin in your company or in your network. You can configure it. The key is it's really this container. This container runs on your local instance, or it will run in the remote. That's the whole selling point of this containerized world. I'm kind of, if this wouldn't work, if I would have difference between my container I'll use locally in development, and then I still have to do something to get it into a staging or production environment, then the whole concept of containerized worlds is broken. Because this is like the holy grail we are after.
Yeah, I'm not talking about
So like which kind of ports they need to each other. That will be exactly the same. That's kind of an abstraction of Docker to a certain degree, and also of OpenShift. And they will, like, if you set it up properly on your local machine, exactly the same thing will happen in these other environments. But you will have to sort it out once at least. Any more questions, or then yeah, one. Yeah, that you would kind of control this by this resource level. Not so much by image, but by application. And it's not, you're basically running one image of the application. You can roll back to previous images, but I think what you're saying is, like, I have multiple, like my application consists of 5 different containers. And you want the 3 front-end containers to have, preferred CPU cycles or something like this. You can configure that. You can also, there's a way to kind of, if you have the infrastructure, I was kind of just saying, okay, here are the nodes, here are the minions. You can also you can also group them. You can say, okay, maybe you have your cluster is not homogeneous. So not all your nodes are the same powerful. So you have some nodes which are good for the backend task and some nodes which are good for the front end. So you can basically give these nodes labels like front end, back end, and then you can, in your build config, you can say, this application or this container goes onto a node of type front end or of type back end. So you can separate or kind of organize your nodes as well to kind of get also a little bit what you're after, to kind of have different resource utilization. Okay.
So that is supported automatically in OpenShift or not? The resource management.
Come again?
The resource management I asked about was image 1 consumes more energy, more resource than image 2. So in this context, we can give weights to the image 1, right? And as you showed before, there's a resource constraint that we can set CPU, RAM, but it would be great if we can give the weights flexibly, if it's possible, So
like even dynamically.
Yes.
All these APIs, also this auto-scaling, are pluggable. There are default implementations for that. I'm pretty sure what you're kind of asking, like really dynamically kind of change these weights, that doesn't exist yet. If there are plans for doing that in the near future, I don't know. But sure, it kind of makes sense. And I think the architecture itself is ready to do something like this, but I don't think this in particular would be implemented. You would kind of need to kind of also hook up some sort of metrics. First, you need kind of to understand some metrics and pass them to kind of then do your actions upon the resources. Okay, I think I'm pretty much over my time now. So thank you very much.